This video is for students pursuing Masters in Structural Engineering. Many students approach me regarding their dissertation area topic, and I reply them that the structural engineering is indeed a very vast area, so that you can select an area of your interest and then you can carry forward the research. So in this video, I have summarized around 30 broad areas out of which a dissertation topic can be selected. And these areas I have selected based on the practical difficulties in the industry. So to start with, the topic number 1, which I have mentioned, is the design of steel structures as per section 12 of IS 800 2007. So when IS 800 2007 was released, section 12 was included for the earthquake resistant design of structures. And there are many practical difficulties when the structure is designed exactly as per IS 800 2007, including section 12. So this could be one of the dissertation area. Second area may be design of eccentric braced frames as per IS 800 2007, again as per section 12. In section 12 it is mentioned that whenever we are adopting eccentric braced frame, then we have to refer the specialist literatures. So the exercise can be carried out, and then practical guidelines may be or it may be compared with the other frames like ordinary concentrically braced frame or specially concentrically braced frames. In IS 800 2007, section 10 is included specifically for connection design, and connection design as per IS 800 2007 is very much stringent as compared to the earlier working stress design method code. So this could be one of the area of the dissertation wherein practical guidelines or design tables can be prepared, which can be directly used into the industry for the connection design. Okay. The fourth area is plastic design as per IS 800 2007. In IS 800 2007, in section 4, plastic design is recommended for steel structure, and for there a certain set of guidelines have been given. So typical or few structures may be taken, and then for that plastic analysis may be performed, and those structures may be compared with the conventional analysis, and the results in the economy or the practical difficulties may be highlighted. Topic number 5 is gap between software and IS 800 2007. So I believe that there are so many gaps between IS 800 2007 and the current software. So that kind of exercise may be undertaken in a dissertation, wherein the few classes may be explored from IS 800 2007, and then it can be seen that whether how the software is considering those classes, and the gap areas may be identified, and further action can be suggested in the dissertation. The topic number 6 is the conventional structure design versus the PB structure design based on the latest MBMA seismic guidelines. In PB structure design, sometimes they are designed using MBMA guidelines. So for MBMA, recently in 2019, a seismic guidelines have been suggested. So based on those seismic guidelines, the structure may be designed, and then it can be compared with the conventional design or the structure which is being designed completely as per the IS 800 2007, and the tonnage and the other details can be compared. Okay. Topic number 7 is a design of PB structures with and without seismic guidelines, which has been published by MBMA in 2019. So the effects on the structure can be compared, effects on tonnage can be compared. Okay. The topic number 8 is a lateral torsional buckling of steel beams. In IS 800 2007, there is an annexure E, and in annexure E, detailed formula is given for the lateral torsional buckling. It's a 3-factor formula including C1, C2, C3 factors. So for this formula, the study can be undertaken, and how much impact is there on the design when this formula is not being considered. So the study may be undertaken with respect to this formula, which is mentioned in annexure E. Topic number 9 is a dynamic wind load calculation as per IS 875 2015 part 3. IS 875, as we all know, has been revised in 2015, and thereafter for dynamic wind load calculations, the methodology is suggested in IS 875 part 3 2015. So based on that methodology, few examples may be worked out, and maybe some kind of charts or graphs or details may be prepared, which may be useful to the industry. Topic number 10 is the requirements of non-linear analysis as per section 12 of IS 800 2007. In section 12 of IS 800 2007, it is mentioned that the structure should withstand the inelastic displacement with respect to rotation of say 0.02 radian to 0.04 radian for different frames. So for those kind of requirements, the analysis may be undertaken, and the impact on the structure may be studied. Topic number 11 is anchor bolt design. Now for anchor bolt design, we do not have Indian standard code. So the study may be undertaken and the guidelines may be prepared for the design of anchor bolt and which may be recommended to the Indian standard codes. Topic number 12 is second order elastic analysis. It is suggested in section 4 of IS 800-2007 that when Ky and Kz factors are greater than 1.4, then second order elastic analysis is required as per Annexure B. So those kind of analysis may be undertaken, and then it may be compared with the conventional analysis, and then we can see the impact on the structure. Topic number 13 is a soil structure interaction. In IS 1893 part 1 and part 4, it is mentioned that whenever structure is standing on rocky strata, that is when n is greater than 50 and when shear wave velocity is greater than 760 meters per second, then soil structure interaction is not required. For all other cases, soil structure interaction is required. So meaning for majority of the structure, soil structure interaction would be required. So those kind of areas may be undertaken, like soil structure interaction may be performed for the soft and medium soils, and the impact on the structure could be studied. Okay. Topic number 14 is non-linear time history analysis for verifying the collapse mechanism of the structure. In IS 1893 part 4, which is for the industrial structures, it is mentioned that for important structures as well as the structures which are located in the highly seismic zone, for those kind of structures, non-linear time history analysis is required for verifying collapse mechanism. So for those kind of structures, this kind of analysis may be performed, and then again the results may be compared with the conventional analysis, and the impact can be studied. Topic number 15 is irregular modes of oscillations in principal directions. Now there are many practical difficulties with respect to these provisions as per IS 1893 part 1 2016. So the study may be undertaken, and then based on those studies, certain recommendations can be made. Topic number 16 is a torsional irregularity. For torsional irregularity also, different kind of structural systems may be studied, and based on that, guidelines may be prepared. Topic number 17 is effect of stiffness modifiers in analysis and design of structures. Stiffness modifiers are different in IS 1893 part 1 and in IS 16700. So impact of stiffness modifiers may be studied on different kind of structural system, and then based on that, certain conclusions may be drawn and guidelines may be prepared. Topic number 18 is the gravity column design. For gravity column also, there are a lot of confusion in the mind of practicing engineers. So certain examples may be taken, and then gravity columns may be designed with respect to the guidelines specified in the code. In topic number 19, one of the existing or say proposed school building may be studied, because I believe that for the school building, the performance based analysis should be carried out. So one of the school building may be taken, and then the performance based design may be carried out to evaluate the performance of the building. Topic number 20 is a time period for calculation of seismic load. Now the formula which is suggested in IS 1893 part 1 2016 for time period for different kind of structural system has created a lot of confusion, because after release of the code, amendment was released, and there are difference of opinion in the mind of structural engineers. So this kind of area may be taken up, so certain exercises may be carried out, and then based on that, certain guidelines may be prepared. Topic number 21 is a flat slab structure design as per IS 1893 part 1 and as per IS 13920. So as we all know that the flat slab system do not perform well during a seismic event. So this kind of structure may be designed and detailed out as per the requirements specified in IS 1893 part 1 and IS 13920, and then it may be compared with the existing structures, or maybe further guidelines may be prepared for this. Topic number 22 is a strong column and weak beam concept. Now it is specified in IS 13920 that the column should be stronger than the beam, so that the plastic hinge will be formed in the beam during seismic event as compared to the column. So this kind of exercise may be undertaken, and based on that, certain graphs, details, or charts may be prepared, that so that the practicing engineer can select directly the sizes of beam and column based on this criteria, so that trial and error may be reduced. Topic number 23 is a design of shear wall. So in this area, shear wall may be designed manually with respect to the different literatures available, and then it may be designed with the prevailing software. And then those results may be compared, and based on that the gap areas may be identified, and then certain conclusions may be drawn out of it. Topic number 24 I have written down is comparison of different software for seismic analysis and design of different kind of structures. So in this exercise, different softwares may be taken, and then those softwares may be compared, and based on that, so certain conclusions may be drawn, and then certain guidelines may be prepared, which may be useful to the engineers. For topic number 25, nonlinear dynamic analysis may be carried out for the structures for which irregularities are increasing even beyond the mathematical limit specified in IS 1893 Part 1, 2016. Topic number 26 is performance-based design of say one of the residential apartments or say commercial building. So we may take details of existing apartment building or say commercial building or say proposed building, and then we can carry out the nonlinear dynamic analysis, and then just to see what is the performance level of that building. In topic number 27, I have defined as a performance level of the hospital building. For performance of hospital building, it has to be in occupancy category, because it is very critical for the patient. Like the patients cannot run away during the seismic event. So we may take a detail of any existing hospital building or say of the proposed hospital building, and we can carry out the nonlinear dynamic analysis just to see that what is the exact performance level of that building, and based on the analysis, further recommendations may be made. Topic number 28 is optimization for the wind turbine generator foundation. This is the most complex foundation design which I have come across in my career. So the optimization exercise may be undertaken because the raft diameter will go at least in the range of say 20 meter. Thickness of raft will be around in the range of 2 meter to 3 meters. So it's a huge raft supporting 130 meter or say 160 meter tall wind turbine. So it's a very critical foundation design. So for optimization of this kind of foundation, the exercise may be initiated. Topic number 29 is again related to wind turbine generator. The tower which is supporting the wind turbine, for that the study may be undertaken for the optimization of the tower, like what should be the construction material, whether it should be steel, whether it should be concrete, or whether it's a post-tension concrete. Topic number 30 is a diaphragm wall design for deep excavation. So for design of tall building, definitely diaphragm wall design becomes a very critical element. And for these, interface between structural engineer and geotechnical engineer is required. So the study may be undertaken in which different kind of diaphragm wall may be designed, having different kind of complexities. So these are the 30 broad areas which I have suggested for the dissertation area based on my experience. Still, there are many other topics which may be considered for the dissertation. I will request other practicing engineers also to write down their suggested area in the below comment box, so that those may be taken up by the students for their dissertation work. And students can also write down their comments below if they have further doubts on these 30 suggested areas, or any other things if they want to mention. Please mention in the comment box below. Thank you.